In this course, we shall learn how to build deep learning based products in diverse domains, starting from the data, the model building, model evaluation, model corrections, and then shipping a deep learning product. We shall also go from fundamental machine learning theory to state-of-art deep learning models. But given that the programming language we shall be using throughout this course is going to be Python, we'll have this Python crash course and TensorFlow installation section, in which we shall learn all the Python necessary for this course, going from variables to conditional statements, loops, classes, decorators, generators, and popular libraries like NumPy and Matplotlib. Then we shall introduce the core machine learning theory and use this theory in solving several problems while building our own mini deep learning framework. And talking about frameworks, in this next section, we shall dive into TensorFlow 2. We'll start by understanding how this TensorFlow 2 is structured and how to make the best use of TensorFlow in coming up with deep learning solutions. Also in this section, we shall look at a special type of neural network called convolutional neural networks and the recurrent neural networks. Using the convolutional neural networks, popularly known as ConvNets, we shall build an image classification system, and then using the RNNs, we shall build a sentiment classification system. Then after getting all these fundamentals right, we move to the first domain of application, which is in computer vision. The first computer vision project we shall work on is that of breast cancer classification, where we shall use tissue data or breast tissue data obtained from a microscope to predict whether an input image gotten from those tissues is one which contains cancerous cells or not. Then we shall see several corrective measures which could be applied to make our model more robust, as this kind of data sets tend to be imbalanced. Then we move on to object detection. That's the second computer vision project we shall work on, where we'll start by using the YOLO version 1 to correctly classify and detect objects in an image. And then we shall move on to the YOLO version 3, which is a better version or a better variant of the YOLO version 1. Apart from using state-of-art models like the YOLO model, we shall also see how to build our own custom data sets. Now, looking at this kind of data set, or looking at this kind of problem in which our data set is composed of input images and an output, which is either you have a cancer or not, it's easier to annotate them, since once you've gathered the images, all you need to do is to say whether the given image is one which contains cancer or not, or one which is made of cancerous cells or not. But with object detection data sets, we not only have to correctly say that in this image we have a car, a person, truck, umbrella, car, person, car, and then we also need to specify that this car, for example, is located at this exact position using this bounding box. So we'll see that if we have to build this kind of data set given inputs and annotations, it becomes very tedious. So we shall look at tools which we will use to make this kind of annotation tasks very easy. Then we move to object counting. In object counting, we shall see how to get this kind of inputs and train a model which is able to generate a density map which can be used to count the number of people in this image right here. We shall go in depth in understanding the generation of this density map and how to train such models. And the next will be image segmentation, in which when given an input, we shall train a model capable of separating the objects from the background. All these projects will be done using TensorFlow 2 best practices to make your work as easy as possible. Then we shall move on to natural language processing. After studying recurrent neural networks and convolutional networks in the master neural network using TensorFlow 2 section, we shall now look at more advanced recurrent neural networks, like for example the sequence-to-sequence model, which could be used in translation tasks. Then we shall look at attention models and also the transformer model. All this will be done from scratch, and you get to understand in depth how all these models are built. So after the translation project, we shall go to question answering, where we shall use a squad data set to train a model which, when given a question like this, or rather which when given a text like this, and when posed a question, like in this case, what is the process of constructing a building or infrastructure, it's able to select the region in this text where the answer to this question lies. So here we have, for example, ground truth answer, construction. So it's basically this, and we see that our model could also pick out a series of words like 6 to 9% is here, and not just only a single word. This will be done using the transformer model, and then we shall use a special kind of attention model known as the LSH attention, which happens to be more efficient than the attention model which was used in the original transformer paper. From here we shall move to speech data, where we shall build a speech recognition system which takes as input sound and then output transcriptions. Here we shall go in depth in understanding how sound data is treated before passing into a deep learning model, and also how to train such models. The next will be an image captioning system, in which when given this kind of inputs, our model is able to come up with such tags. For example, here we have a tan dog is playing in the grass. From this we move to generative modeling. Here again we are going to go in depth in understanding the generative adversarial neural networks, which are popularly known for their application in data generation. As we could see here, all these images are fake, as these people don't actually exist. Finally, we shall ship a deep learning product which can be used anywhere in the world. For every project we've listed out here, you shall be expected to build your own project, which is meant to be personalized. You also have to be able to document and share your work, as this will make you grow faster and further in this domain. So firstly, you have to upload all your projects on your GitHub account. You also need to share your projects on LinkedIn, Twitter, YouTube, and Facebook. But you are advised to have at least 3 out of this. So we suppose firstly you must have at least a GitHub account, and then you have to pick, say, at least 2 out of the 4 in which you shall share your works. Let's also include Medium, so you could pick, let's say, 3 out of those 5 plus your GitHub account. And also in this last project, you shall be expected to gather your own data and not just use already made data. Also, we lay much emphasis on feedback, so In cases where you have any difficulty, you could always get to us in the class forum.